Following on from the previous two videos, we wanted to know the component of this vector u in the direction of I So the way we would do it, we would project the vector u on top of our unit vector I here, on top of this unit vector I here. So our final answer, well, we would project this thing down here. So our final answer was this vector here. Our final answer was this vector here. And the way we did it was by projecting u on top of the unit vector I. And then that gave us this answer here. So we would calculate this thing here. So the way we did it in the previous two videos was we would calculate the dot product. So it would be this times this, and then this times this. So that would then give us 3, and we would blah blah blah. That would then give us this. This was our final answer. The point I'm trying to illustrate here is that the point I'm trying to illustrate here is that you projecting vector u on top of I here. That's because this is a unit vector. You can just simply perform the dot product, and that would then give you the whole thing here. So the point is that if you want to know this component, if you want to know the component of u in the I direction, then rather than doing this, you can just simply do this. You can just simply perform the dot product of the vector u and the unit vector I. You can just simply do this. That rather than doing this whole thing here, and try to understand why. Because when you're working with a unit vector, if you perform this, if you're working with a unit vector, the magnitude of the unit vector will always be 1. And then when you square it, it will always be 1. So even if you're working with rather than I hat, you're working with j hat. So this would be 0, 1. Then the magnitude of this will always be 1 because it's a unit vector. Square it, it will be 1. And so this thing here will then give you this. But then when you times a unit vector, so in the direction of I, it will be 1, 0. When you times this, it will be a number times this, a number times this. You see, you're really just extracting the first element of, well, this times this will be 0. So because of this 0, you don't really care about it. If you're working 3D, let's say 1, 0, 0. You've got a number here. So really, this times this, these two are going to be 0. So you're really just extracting the first element. If you're working in the j hat direction in 3D, it would be 0, 1, 0. When you come, so you're going to have a number here. So this times this, so you're really just extracting the middle element. You don't really care about these two. The point I'm trying to make here is that if you want to know the components of this vector in the I direction, rather than doing this whole thing here, you can just simply do the dot product. You can just simply do the dot product with the unit vector I hat. Okay, so let's extend this into 3D. Let me illustrate this. So let's say we've got a vector 2 in the x direction, 3 in the y direction, and 4 up in here. So this is our vector here. If we want to know if we want to know the component of this vector u in the direction of x, we would just simply do this. We would just simply get our vector, dot it with our unit vector in the I hat direction. Well, in the x direction. So that would then give us this. If we wanted to know the component in the j hat direction, we would just simply do the dot product here. That would then give us this. If we want to know in the k direction, then we would just do the dot product here, and then that would then give us this. And let's try and understand this in the algebra perspective. Hang on, let me think. Where am I? So let's try and understand this from the algebra perspective. So we've seen this in the past. If you don't understand this, then track back to one of the earlier videos. this really stems from the cosine rule. Um, that led us to this. When I first introduced you to the dot product, we actually used this. This here is a dot product. This bit here. Well, you should have already seen this. So now times both sides by this whole thing here. So that will then give us this. So now let's say you want to know the component of this vector. So you would project it onto this unit vector here. So basically, we want to know this component here. We want to know this vector here. So we are projecting u onto I here, I hat. So the component of u along this direction here would be well, if you use trigonometry here, if you want to know this length here, you would get the magnitude. You would get this length here, which is the magnitude here, and then you would times with the cosine of the angle. So this is basic trigonometry. Let's say this is 7. Work out x, where the angle is theta, blah blah. If you want to know this length here, it would simply be this. Now, so when you're working with unit vector, the magnitude of this will be 1. So you can just simply insert the magnitude into here, and then that will then give you this. Because when you're working with a unit vector, the magnitude will always be 1, even if it's j hat or k hat. The magnitude will always be 1. So you can insert it into here, and then now if you look at this, this is pretty much near enough our definition of the dot product. So this thing here is really the dot product. So you wanting to know this component, you wanting to know this vector here is the same as you working out the dot product with a unit vector. Okay.